Hello everyone. Today we will be discussing a very basic yet very important small topic, that is atomic orbitals. I'm sure you all would have already heard about this term atomic orbitals, which comes under the topic structure of atom. However, this topic is very important for you all to have a good understanding because it helps you understand better the topic of chemical bonding followed by organic chemistry topics. Because if you understand atomic orbitals properly, you will automatically understand chemical bonding properly, and hence the basics of organic chemistry could be very clearly formed. The base of it would be formed with much solid understanding if you have a good clarity about these small yet very important topics. Okay, so let's start. Okay, so you all must have already heard about Heisenberg's uncertainty principle, right? The uncertainty principle, according to which finding the position and momentum of a particle simultaneously is not possible. So in light of this principle, the Bohr's postulate that electrons revolve around a well-defined circular path, and hence knowing its position and momentum simultaneously with accuracy is not acceptable. Okay, and hence the new model, that is quantum mechanical model of atom, came up, isn't it? So this is all about probability of finding an electron. It is about probability of finding an electron. Now let's focus on what this is, okay? Because what we are trying to understand, the answer lies in this, okay? So let's consider a very simple analogy here. Just consider a bee around a hive. So our bee will be the electron and the hive will be nucleus. So just like a bee, an electron can move around the nucleus. It can sometimes come near the nucleus, sometimes it can move away from the nucleus. Similarly, it can move in all directions around the nucleus in three-dimensional space, and it can move in any of the planes around the nucleus, which was incorrectly said by Bohr because it restricted it within a circular path within a plane, right? Now, to understand this probability of finding an electron and hence our main topic, atomic orbitals, let's consider a hypothetical experiment. For that, let's consider the most simplest atom, that is hydrogen, with just one electron. So we are going to talk about this one electron. If we take photographs of this electron, okay, so like if I just click one photograph, it is represented by a small dot. In a similar manner, I take photograph of this electron multiple times within a very small intervals of time, literally like instantaneously. And once I have all the photographs, what I'll do is we'll overlap it, or we can say superimpose it. Okay, so in case of hydrogen atom, when we superimpose those images, what we get will be something like this. Suppose this is my picture frame. Okay, what I will be getting is something like this. Each small dot is representing an electron in that one particular image. So here what I'm doing is I'm overlapping all those images that we took, okay, for each small interval of time t, let's say. Okay, okay, so what you will get is something like this. Okay, just okay, so the image would be something like this. So what are your observations of this image? Let's just quickly see the observations. What are the first one? You see the position of electron. Okay, the position of electron is within, okay, within a certain distance from the nucleus, right? Isn't it? Then it's very obvious, right, that probability of finding this particular electron or any of the electrons, if we take a picture like this, will be directly proportional to intensity of dots. So based on that, we can say that implies that electron spends most of its time within a volume around the nucleus bound by a certain distance. The certain distance is this distance that we just discussed. Okay, isn't it? So from here, what I'm trying to say is that based on the image that we see, electron most of its time, it's around a certain volume in space within that distance. So in particular, in case of this image, what is happening? It's within a certain spherical volume around the nucleus within a certain distance from that nucleus of hydrogen atom. So here I would like to introduce a new term, that's electron cloud. Have you heard of it? This just very important term because you will be often listening or coming across this term electron cloud when you'll be dealing with organic chemistry in order to explain various phenomena, various effects, and the way the bonding and breaking and formation of bonds happen, or the stability of molecules. You will be very often using this term electron cloud. So let's see what that is. Okay. So electron cloud is precisely what I was talking about here, about this particular certain volume. So electron cloud is that particular volume around the nucleus, volume around the nucleus, which describes the probability of finding an electron of certain energy. Okay. Now, so it is that particular certain volume around the nucleus which describes about the probability of finding an electron of certain energy. Okay. Now, you need to note something. That is, nowhere around the nucleus is the probability of finding an electron equal to 0. What does this imply? Even at a very, very large distance from the nucleus, there is a finite, though small, probability of finding an electron of a given energy. Based on that statement, what can we imply? We can imply that electron cloud do not have a sharp boundary, isn't it? Because the, anywhere it could be possible in reality, right? So there is no sharp boundary, like the electron cloud doesn't have a sharp boundary. However, in order for clarity of what to say, the pictorial clarity which we will be often using, and for the convenience of what to say, understanding or representation, we will draw a boundary surface such that it encloses a volume within which the probability of finding an electron is maximum, that is up to 90%. And it is precisely this volume which represents, within which the probability of finding the electron is maximum, is known as atomic orbital. So if we have to define atomic orbital, what is atomic orbital? Atomic orbital is the three-dimensional space around the nucleus within which probability of finding an electron of given energy is maximum, that is up to 90%. What is the difference between atomic orbital and cloud? See, here what we are doing is we are not setting any boundary, right? So that's why we are talking about the entire probability. We are not setting any sharp boundaries here. Whereas for convenience purpose, we draw a boundary surface. How do we draw this boundary surface? We will draw a boundary surface along the points having equal probability. So like if in this case, if we kind of like draw as something like this. Okay, sorry, my drawing isn't very accurately a circle, but then it will be a circular image which is actually representing a three-dimensional sphere. Okay, within which, around the nucleus, within which the probability of finding an electron will be maximum. When I say maximum, it would be close to 90%. So that means within that volume, most of the time the electron will be present. So that is what is atomic orbital, the three-dimensional space around the nucleus within which the probability of finding an electron of given energy is maximum. It is maximum three-dimensional space within which the probability of finding an electron will be maximum. Now let's quickly do a comparison between an orbit and an orbital. I think most of you would have always had a thought at least once that what is the difference between between these two, right? What's the first point of difference? This is a well-defined circular path along which the electron moves around the nucleus. So this is talking about a planar motion, whereas orbital is a three-dimensional space around the nucleus. Basically, the definition, you already know that, three-dimensional space around the nucleus within which the probability of finding an electron is maximum. So this describes the three-dimensional motion of electron. Okay, what could be the second difference? It is, this is the shape of an orbital is circular, whereas in case of an orbital, the shapes differ. For example, in case of an s orbital, it would be spherical. That's exactly what we saw in case of hydrogen. Here, isn't it? This one. Whereas if it is, say, a p orbital, it would be dumbbell, and so on. We'll see the other cases also. Then, what would be the third difference? There is no directional property here, or let's say directional characteristics in case of orbit, whereas here there is directional characteristic in case of orbital. Now I won't be explaining what is this directionality, that I will discuss when I'll be sharing the videos on chemical bonding, because that's where it comes into use. Okay, so just keep it in mind, the difference. Then the fourth one, the maximum number of electrons in an orbit is 2n square, where n is what? The number of the orbit. Here the maximum number of electron in an orbital will be equal to. So that's the difference between an orbit and an orbital. So we, here what all terms are very important that you need to keep in your mind. Electron cloud, what that is, because that will be very useful for organic chemistry topics. Obviously atomic orbital, that's our main topic. And this for your conceptual clarity, the difference between orbit and orbital. I hope this would be a useful video for you all for better understanding of this simple topic, atomic orbital. So for more videos, come and join our channel so that you can get all the updates and videos and contents regarding chemistry class 11 and 12. I'll share both classes, and see you soon.